So, ist es geboren?
Oder in den Zeichen.
Wir sind jetzt live.
Okay, we're live. Okay.
It's okay. We can do a quick
Okay,
start.
okay.
That's perfectly fine. I just need this one so that everybody can hear me, and I will give it back to you. Stefan, are we live? Very well. So I think we should get started. We are here in Linz at the Ars Electronica Festival, and we have a very special guest here. Lisa is here, and she will do a workshop with the title Rust for Artists. And without further ado, I would like to hand the microphone to you so you can get started. You are.
Thank you.
The workshop will be, of course, not just live, it will be recorded, and you can find it on the Rust YouTube channel after the conference too.
So, thank you, Anna. Okay, so for the camera and everybody, there's also people in the room. Hello, welcome. It's so cool that you're here and that you're interested in the topic. So Rust for Artists, we will do a little quick round of introduction, like what is your background, what are you especially interested in? Because our time is kind of limited and Rust is a big topic and art is a big topic. So we can kind of see which bits and pieces we can maybe try out, or if you say, oh, I have no idea, I have also something prepared that we can work on and discuss things along the way. Cool. Who am even I? Why am I standing here? Why should I talk about this? I'm Lisa, first of all, hi. I'm a creative technologist, doing this in a self-employed manner for 2 years now. What does that mean? It means that I really just want to play with technology and kind of make a living off of that, with varying success, I would say. But I build things I open up electronic kids toys and try to play with them with lots of Arduino stuff, but also fun interactive web applications. I've not yet been paid to make a game, but if you want to pay me to make a game, I would love to. Just putting that out there. I've been around the Rust community since 2016-17, which I was jumping head in first, just oh, there's a Rust conference. I submit a proposal about making games, and it got accepted. And I was oh my god, I have no idea what I'm doing. And today, I think I know a little bit more than I did back then. But let's see, at least enough to talk to people about it. And I'm also super proud that last year in November we put in an online conference called Rust and Arts, which combines these two areas of my life, Rust and also art. This is a screenshot from where I was doing a little intro talk with Kyle, who did something with pen plotters, which was really cool, where he wrote an entire operating software for a pen plotter and also how to design the plots and everything. It's all Rust. It was really cool, and these kinds of ideas. So that was really cool. So I know a little bit about Rust and a little bit about art, I would say. And this is the moment where I ask you, who are you? Why are you here? Maybe just maybe say your name and kind of what your background is, one sentence, and then what you would like to learn today. One sentence. We start in the front.
Okay. Hi, I'm Paul. I would say I'm more of a corporate programmer, so Java ecosystem. And I would really love it if we could have something like a pseudo-random image generation.
Okay.
Landscape stuff, something like that.
So AR, AI style already, or just very simple?
Yeah, just some noise.
Okay. Yeah. Okay. Cool. So you use the word Perlin, so you kind of know a little bit about tools in the sphere. Okay, perfect. Okay, cool. Thank you, Paul. Then go.
I'm Matthias. I'm a university student here, and I've already good experience with Rust.
Okay.
Yeah, I really enjoy AI generated art and also abstract art. Yeah.
Cool.
I'm also a student here. And I would like to pick up a little bit of Rust because I have almost no experience.
Okay, cool. All right. That's perfect. It's a good mix of, so I can kind of try to, because I've never worked with Java, but a little bit with Clojure, so maybe I can find some similarities to draw, or to compare it to, but a little bit of Rust experience, or a lot maybe. Let's see. So I will come to you for maybe what do you think about this? and hopefully like pick up everyone's like where people are, and like we learn a bunch. Okay, let's talk about Rust. Since you're here, I assume you kind of know what it is, so I will keep it short. But I do want to quickly, let's see, Rustling. Want to make a point about why I think it's actually a cool choice for artists as well. So this is the Rust website. You've probably seen it. And when the website tries to make a case for Rust itself, it has these things like performance, reliability, and productivity, which are obviously important in a corporate environment. But I also think they are very important in an artistic environment, because like if you build an installation or if you like have something running somewhere, you want exactly these things as well. When I hear stories of like people who build like a larger thing for what was it, a museum, and they think like, oh, it had like sound components and like just like it was supposed to run for a year, and they're like and they were like imagining writing this in C++. It was just like, it gave them nightmares. So this is like, it's an actual story of like people like that, but then they chose Rust so that they know once it compiles, it will just run as long as nobody touches anything. So this is the kind of like idea that I think is like Rust is very suitable for these kinds of artistic, playful things that we can use. Also, and I think this is another very cool factor, is that Rust runs everywhere and can do a lot of cool things. So from embedded, so we can like program so arguably the ecosystem is not quite there yet, but like thinking of programming our Arduinos or like Raspberry Pis in Rust, like reading from like physical computing, reading from the environment. But we can also do everything we need to do, but networking. We can build our apps and have them cross-compiled to Wasm, so they run in the browser. We can share them, and we can do all of this in Rust without like having to switch languages. We can often like put them all in the same project, and I think this just eliminates a lot of overhead in like trying to figure out, okay, here I need this, and then maybe write a node server, and then like choose this front-end framework that has its own build setup, and all these things, and we can like just have one thing in Rust, and that's, I think, is also really cool. That is that. A little plug, because I think Rust is cool. Right, so this was the short intro part, but since this is a workshop, this is supposed to be like hands-on, and this is a little checklist that you would need to like follow along. So ideally you have Rust installed. Nodding. Yes, cool, check. If not, you can click here. There's it's a one-line copy-paste thing from the Rust language website. You would ideally have your favorite editor. I will use VS Code in this workshop, which is not what I usually use, but this is also not the laptop that I usually use, so yay. And optionally, I recommend installing Rust Analyzer for a lot of like nice things that it gives you. I will show you what Rust Analyzer gives you in a moment when we switch to the editor. But this is optional, but it's really cool. And another like plugin for Cargo, if you don't know what Cargo is, I will say so, like explain it in a second as well. But especially when you work on a sketch or like something where you need to do a lot of changes, something like Cargo Watch, which like watches your changes, can also be useful. Then I prepared a workshop repository. Let's see if I can. Here we go. I forgot attention. Yes. I prepared a HackMD. This is where we can all, or like where you can like post questions, or we can share links. The link is hackmd.okev.de/RFA, like Rust for artists, -AE, Ars Electronica 22. And then you should see something like this. And there's this cool thing where you can do split view, so you all should have the same access to this. And on the left side, you can write Markdown, and on the right side, then you can see the rendered Markdown. And now it also just like, so ideally I should have given you this link beforehand, but I forgot. But I'll put the repository link just in here. So it's there for you as well. And from the repository, you can just clone the repository, or if you want to also just download the zip and unzip it, that works too. The important part for this is actually everything that is in code and then in walkers. Maybe in the future there will be more in other examples, but we go with this one for now. And if you, yeah, cool. Thank you for sharing the things. Hello. You here for the workshop too?
Yes.
Cool.
Have you already started?
We already started. Yeah. So we're going through the setup, like checking that everything's ready.
I think that's a big setup.
Cool. Right. So maybe I write like the link later as well. If you have the workshop repository, the first thing that I want you to do is actually like go into code/walkers and run cargo build --bin and then final, which will then download all the dependencies, which takes a lot because the framework that we use has a lot of dependencies. So this will take a moment. So I just want you to start with this so we can like work with that in a moment. So I keep this open for now. And then while everybody like maybe goes through the list, we can maybe have a first round of questions if there's anything unclear or no, okay.
We haven't shared the workshop repo link yet.
Okay.
Now is if you want. I think you all know the Rustlinks Discord. It's just posted for you. You just came here, so I think
it's on YouTube and it's on the Rustlinks Discord. Oh, it should be there, but it takes a little time until the message is implemented. But it should be there.
Cool.
No, but I do need to write that password.
There is no password. Like all these parts electronica is for free. Okay, just
Okay, I'm sorry.
How's the download going? Is the internet okay for Ghost? Okay. Let's see.
we should be in the code walkers directory, right?
Yes, exactly. And it will just, the download takes a couple of minutes and like until everything's ready. Cool. But if that works, like if things are like running and downloading for people, I can like go a little bit further without jumping into the code straight away. Do you have not like, okay.
No, I don't.
Okay. Let's see. How did I do this before? I just give you, so I have, maybe this one is easier. Yep. Because then I can, no, I have trouble with internet, it seems.
Okay, so
yeah, so this is the workshop repo, but you can also save the link to this pad if you can see it. I was trying to like maybe copy it in the.
I can barely see it, but I can see
Okay.
this little thing.
Yeah,
I can find it.
that is perfect. I'm also trying to. Yeah. Maybe let's do like this. Did I not?
Yes.
Yeah. Oh, my computer is lagging right now. It is annoying. Okay. techmd.okfn.de/RFA, Rust for Arts, artists-AE, Ars Electronica 22. And then there's the workshop link is in the top, and like other useful links. And you can also share links there. All right. I will switch back to this maybe. Okay. Next. So the first project, or like the project that I want to walk you through, is like a simple, exercise and like a simple or useful and simple tool in the creative coding world, I would say. And they're so-called walkers, or like random walkers, which is just like, basically we kind of like draw random lines. So like imagine a little walker, like a person or a robot, like walking in random directions, and wherever this little like agent, let's say, goes, we will draw a shape or something. They come in various disguises, I would say. I put in 2 links into the slides. I will also put the slides online. There's like a proper link. I will also put this in the notes. But if you like this kind of, so I linked these 2 resources, which are like very cool creative coding resources. One is Nature of Code. They also introduce walkers like in the introduction chapter. Nature of Code is a great resource for like all kinds of creative coding techniques and algorithms. Random walk. All the examples are written or like are use processing, so like the Java-based thing. It's a couple of years old, but it's still like it covers all the bases, and it's really, really cool. So this is the example that is built in Nature of Code. So it's just like a very small, like kind of like draws little like dots where like wherever along it goes. And this is like the basis for a lot of cool things that you can do. And then in Generative Gestaltung, or generative design, that does not have HTTPS. They basically updated this. They use P5, so like the JavaScript version of processing. And they do this like a little bit more advanced of like, it wraps around the edges, and it has like, creates this cool like randomized patterns in the same way, but like the logic is basically the same. And I thought we'd do something like this because it's like small enough, and I will quickly run the, so the thing that you're building right now, if you run it, it looks like this. So the logic is the same, but I decided to write, you can probably barely see it on the screen, maybe in here, is that we also like walk randomly, but we draw semi-transparent circles, but we can even, so you can like change more. I also made it so that you can choose if it's like a square, or also just like small dots, which you can probably not see at all here. No, okay. So you can like switch between like what we're drawing, also create multiple walkers in one window. Right. So that's what we're gonna do. And the tool that we'll be using for this is, I think as of right now, my favorite like Rust library. It's called Nanu. Let's look at the website here. So Nanu is an open source creative coding framework for Rust. Usually people ask, so what's the difference between a creative coding framework and a game engine? And I think the best answer to this question I've ever heard was like, oh, a creative coding framework accepts more inputs and offers more outputs to like various other protocols. So the people behind Nanu are very fond of their lasers and LEDs, so like you can talk to lasers, do a little laser show. I also know that lasers are really, really expensive. This is why I don't have one. But you can like, you can just use it as processing or P5. You can talk, like as of right now, I think it speaks MIDI and Open Sound Control, OSC, and you can talk to like peripherals and like get data and like send out data to these things. This all sounds very funny and like cool and fancy, but we will just draw today. But I hope that you will have enough knowledge, or like enough knowledge of both Nanu and Rust, that you can like then dive into the documentation and the guide and see like how you can use this for yourself and your little projects. Right. So I think I can actually close my things here. Right. So this is all of the introduction and all of the slides. Playtime. And for this, I will jump into the code. No, not safe. Okay, I'll close this too. Quick question, how's the download or like the build is finished? Cool. How's it going for you? No? Oh, okay. Okay. We will also do like a short break. So then we like, if you still need help, we can like, or like I can take a look then. Cool. Wait, it's a little bit smaller. Hello. Oh, hello. Right. So within the workshop folder that I shared with you, in the code walkers, the walkers folder is basically what came out of scaffolding a new Rust project. So I will like quickly explain a couple of things. So if you've never started a Rust project by yourself, when you install Rust, it comes with its own little package manager, and like not just package manager, build tool, everything, called Cargo. And Cargo is your best friend because we can do everything with it. For example, you already seen in the example that I shared, we said Cargo run to like run our software. We can also say Cargo build, various other things. And when we say Cargo, let me just do a little demo maybe. Cargo new, and we call it Ars. And this is all I need to do for me to like to have Cargo scaffold a new project. For me, that comes with just a Cargo TOML and a source directory where there's a main, like this is the default binary project setup. There's also the possibility to create a library project, but like we stick to the binary for now. So this is what we have, or let's say in the walkers directory, there's a little bit more. As compared to like the really like the base, which is the Cargo lock, which will be written once you install other dependencies. You know it probably from other various package management systems that once you like install everything, it will be written down in a specific file. I added a README, and once you compile stuff, we will get the target folder where all our compiled stuff lives. Cool. Then one more thing before we get into the code is, I don't have this open actually. I have another window. Yes, I do. Oh, this one. Because I wanted to take a look at the Cargo TOML. So this was generated for me. Nope, don't. It's just a couple of things to notice that TOML is maybe an unusual choice for these kinds of things. You might be more used to JSON or XML or YAML or wherever. It was definitely when I started Rust the first time I had to like deal with TOML as a format for these kinds of things. We define our package. This is like our project. It has a name. It is the name that I gave it in the beginning. Version is automatically edited, and then there's this key that's called, bless you, edition, which is the 2021 edition. Just a quick note on this is that every 3 years, Rust kind of like makes or like decides on a milestone. Like this is all the features that are currently now in the language, and this is if you use this edition, you kind of like assume that this is the it's kind of like a version of Rust, except that Rust decided to never ever have like to always be backwards compatible and never to like deprecate things, but you kind of like need something to talk about this certain set of features in the language that we want to work with. So the first edition was 2018, and now we have 2021, and then like we will get the next one later. Not to talk too much about this because I actually think it's quite boring when you just want to start with a project, but like I think also the idea that once your Rust project compiles, it will always compile in the future is a great promise, and something that I think a lot of like people in other language communities would be like kind of jealous of. So I think it's very cool. And then, so really just like a small edit is that I defined several of these bin keys here, so like several binaries that live in this project. If you don't do this, Cargo will search for just the main RS, which I then renamed to main, which for us is just basically the blank scaffold for a little Nanu setup. There's also final, which is kind of the thing that I told you to compile that just like pulls in everything. And also will be my little cheat sheet if I get lost, so we can look at final. I gave this workshop once before, which is why you have a version that is slightly different, which is like what we played around with in the first iteration of this workshop. And I will actually be working in the Ars 2022 file, which is just a copy of main right now, but just to like record what we end up doing here. So like if we diverge a lot from like my original path, it will be recorded for history and will live in the repository in the end. And then last but not least, we have dependencies here. So what do we want to pull? Like what do we want Cargo to pull in? And we say Nanu in this version. And that's it. Cool. Okay. I think it's time to ask you if you have questions as of right now. No. Okay, cool. So then let's look at the main RS file, or as I said, I will be working in the Ars 2022 file that you don't have yet, but will be in the repository by the end of the day. And let's just see what is in there. Right. Okay. So at the very top, so this is the idea is mainly just like look at a little bit of Rust syntax. What do the things mean? Why are they there? Why are they cool? How do we work with this? And what is Rust? What is Nanu? And what is me? Maybe at this point. Okay. So at the very top, we have a use statement which pulls in the dependency Nanu that we want to work with. So we say Nanu, and then we have : for namespacing, and then Nanu prelude, and then we have the asterisk or like glob everything that we have in prelude, and we want it here. And this is already like a pretty good example of things in the Rust world if you do it with dependencies, because actually what is not, or like what we can't see right now is that Rust automatically includes its own prelude into our file. So like there's a couple of things we can already use, like certain types, like vector types, for example. They're already included without us having to explicitly import them. And these are also, this is called the standard prelude. And following this prelude idea of like saying, I give you, or like I bundle up everything that you would probably need right away, a lot of packages also define the prelude and say, okay, here's the prelude. You can include everything in there because you probably need it. And this is what Nanu did as well. So Nanu offers us a prelude, like with everything that we need to get going. So we include everything from here. Cool. Next thing that's interesting maybe is that I define a constant. You're probably familiar with the concept. So it's a constant value. And here we see a little bit of Rust syntax, which is defining types on things. If you come from maybe like a dynamic language, this like maybe unfamiliar to you. So let's say we have, I want to define a width that I will later use to define the dimensions of the window that I want to create, and I gave it the type of F32, which is as it says here in the tooltip, a 32-bit floating point type. And this actual tooltip is also something that comes from Rust Analyzer, the plugin. Why did I choose this number type? Because later on Nanu requires me to use this, so like I use it in the beginning. But there's quite a lot of number types in Rust, actually. We will see a couple later. But there's two floating point types, like the 32-bit and the 64-bit, and then signed and unsigned integers in various bit sizes. And they're usually like U, for example, 16, or U32 for like unsigned ones, and then I and the same for the signed ones. And because I always forget to mention that there's also platform-specific number types, usize and isize, which we will see or will be used as indexes into arrays and vectors, for example. But we'll get to this in a second. So we have const name colon type, and then we assign a float. Cool. And then we have some interesting things happening here already. I'll start with line 6, where it says struct model and then just empty curlies. The struct is Rust's way of defining a new type. So we say like, hey, we have a struct, we call it model. And right now this model has no properties. There's nothing in there, it doesn't do anything. It's just like we define this new type. Rust doesn't have the concept of like classes, so it's not object oriented. But like we kind of like build types, and this is everything revolves around this. Later on, some things might feel object oriented to you. Then there's definitely similarities, but there is no real object orientation as you like know it from other languages, for example. Cool. So we have a struct model. Structs are usually written or like start with an uppercase letter. That is that. The more interesting or even like super weird looking part is what comes at the top. It starts with a hash and then like square brackets, and it says derive debug. Does anyone know what this could mean? Or like people who might know it like can say it, but like wild guesses from people who don't know what this might be. Okay, it's completely fine. So every time we have this hash syntax like hash square brackets, and now I have to think because I always mix up the names. It's called an attribute. Yes, because I sometimes say it's annotation, but it's attribute then. And this is kind of like our little message to the Rust compiler saying like, hey, do something with whatever follows this attribute here. And in this case, we want to tell the compiler, hey, I want you to derive, so like basically generate something for our type here, and we want to derive an implementation of something that is called debug for this model. Here's the question, what is debug? And I will actually, and I hope the internet works stable enough for this, introduce you to, actually let's go through the pad. Never rely on internet is a bad idea. Okay, because one of the useful links that I put in here is called Rust Playground, which I highly recommend you check out if you just want to like try out a thing. So we will try out a thing. And is that you get a minimal like Rust playground, like literal Rust playground, where you can like write a little bit of Rust, evaluate it, and see if things work or like what happens. So we have a main function. I'll just quickly also type the little bit that we had in the in our main RS. And the idea is that we have a model, or like we have a type that we created called model. And then let's say I just want to, for example, print this. This is something that would look like this. So like this, I think I'm always confused. We also have to create a new, let's say, this is very small, actually, isn't it? Let's make it bigger. So I created a new variable that's just like where I assigned this like empty, like an empty model thing, and then I want to print this model, and then hopefully I didn't make any other mistakes. Okay, perfect. Actually, not so perfect. Let's do it like this. Yes. Okay. this is the error message that I wanted to appear. So what is happening? So this program doesn't compile. And in this case, it complains. We can see two things. First of all, the nice error messages that Rust gives us when we want to work with it. And second of all, what exactly is happening here. So it tells us that model doesn't implement debug. And this is a very good, this leads us into the path of like how Rust deals with types and like how we construct programs basically. So I said that Rust is not an object-oriented language. It's more that like we create types and then we kind of implement what is called traits. So like certain functionality that is bundled under a name on our types, so that we can kind of like pick and choose. So like I guess the standard example in object-oriented world is you have an animal and then you have like a bird, and the bird has like wings and then and the beak, and then you have like animal, and then animal, or like a dog inherits from animal, and the dog is like fur or whatever, and then you have like a platypus, which is ein Schnabeltier in German, which is kind of like it has some traits of a bird and some traits of like a mammal. I confused it. But like basically like something that is hard to illustrate in object-oriented like programming if you like only have inheritance. But in Rust with the trait system, we can say, okay, we have this animal and has like traits from certain other types, and we can like implement this. So this trait system is really like inherently Rust thing, or like Rust's main architectural feature, I would say, where everything has a trait and like also everything is implemented as a trait. And we can also implement traits on our own types. And one of these traits is debug, which is something that we need to implement our type so that we can print it, for example. The first error message was a little bit different one because it says model doesn't implement another trait called display. I'm running it again so you see this one. Standard format display, which is similar, but like more in like a pretty printing kind of way, which I don't need right now. I'm satisfied with a different kind of formatter, which we can put in with colon question mark in this. I haven't said anything about this. So within the string, we can, or like within the placeholder and the curlies in where we want to replace our value, we can say we want a different kind of formatter to be used when we print this thing. And the debug one is this one. That's the most useful one for debugging. And if I want my type to be debuggable, I need to implement this debug trait. Okay, let's sit on this for a moment. How do we implement the trait? Like, how do we solve this error message? And there's a shortcut. So there's a long version where we actually implement manually a trait on a type. We will do this later, but there's also a shortcut for all these types that are let's say very standard, like debug, or if you have things that you want to compare to one another, or what are other ones? So there's several ones that I don't want to like get too deep into, but there's like simple and easy implementations for them. So easy that we can automatically tell the compiler to please do this for us to save us some manual work. And this is what the Rive debug does. So we say little message to the compiler, hey, for my struct or my type model here, can you please just like auto-generate or implement this debug for me? And then it will do so. And we say, hello model. Our model is not it doesn't really do anything, so we just get like the name of it, but this is the idea of what is happening here and what is the Rive. Okay, cool. I hope you're still following me, because like Rust is a big language and there's a lot to cover, and I hope just we get through the main parts so that you know what's happening here. Finally, really cool, we make it down to our main function. This is the main entry point into a program, as you might expect. Rust Analyzer actually gives me here little buttons that I can click, so I can just like click here and it will open It will run the thing, open a little terminal. You can do that too, but you can also, I usually don't use this one, but like just switch to a terminal to run stuff. Okay. So this is, and then we see what our current program is doing right now. It just opens a window that is black and doesn't do anything yet. But it's cool, it works. So what is happening in main? What is actually going on? We have Nanu, and we create a new app. This app gets a model function. This is interesting because this is more of a Nanu convention that I will talk about in a second. And then we say this app should also update, and the function it should use to update is also called update. So these are like function names. And then we say run this app. And this is all we do in main. And then the rest of the file is basically the definitions of model and update. So we have fn model. So we see fn as the function keyword. So this is a function that is called model. We, as we would expect, have parentheses that take parameters. Or like arguments. Our first argument is called app. We see the colon. So what follows is the type definition. So what kind of type should app be? Surprisingly, it should be of type app, which is what we get when we call Nanu.app. And interesting also here is the ampersand. So we get a reference. So like we don't give over anything or like the ownership to this model function, but just a reference to it. And what we want to get back is of type model. And model is the model that we defined. It's our struct here at the top. So it doesn't do anything yet. This is an interesting, so at first when I saw how Nanu tries to, or like the base API, let's say, of Nanu, it took me a while to understand that in the end, it does the same thing as processing does, or P5 does, or like smaller like 2D game engines do, is that they have, or like maybe you're familiar with it, they have a setup or a load function, and then an update or a draw loop. Sometimes, you know, you have update and draw. But this is like the idea that you have like something that runs once in the beginning, really like just like starts everything up, and then some sort of loop that just like runs continuously and that does either the drawing or the computation or both. And in the end, Nanu does the same thing. They just call it different things. So the naming is a little bit weird because the naming is kind of like a model view controller adjacent naming. So they have this like idea of model is supposed to be your state, where you like define state as like Rust structs, and like your draw loop is called view for whatever reason. Funnily enough, there is nothing that is actually called controller, but like in their reasoning, it was like, okay, we kind of like want to like architect our API similarly to like model view controller, which is like, okay, it's a choice. I was kind of like confused at first, but you get used to it, and that's fine. So in this idea is that like the function model is what is usually like your setup or load function. So it's the thing that builds everything in the beginning, prepares everything, and runs once. So since we can actually like choose the naming for this one, we could also call this setup here, and this setup here. Like in the Nanu guide and the Getting Started guide, usually this is called model. We also like already like yeah, okay, a complaint here, but let's do this back. So that's kind of like where we were at before. Okay, right. I'll quickly walk through the rest of the model function just to like know where the rest is happening. As I said, model is kind of like the setup where we construct everything. So here we like basically say we use this app again that we get as the Nanu app creates this, hands it into the model function. So we get this from like our arguments here. And then we like build it in the way that you may be used from other things. So we say we want a new window. The size of the window should be, and here comes our constant width. So actually I have to typecast here. So now I'm not sure where I need the width again and why I chose float in the top. But here I say basically that I need not the float value, but I need it as a U32. So I need to like convert it to a different number type. And for height, I also use width, and like Rust Analyzer tells me here, actually this parameter is called like height, just in case you were confused. But I also use width here, so we get like a rectangular, like a square window, because I like those. Also typecast here. And then we say, similar to like how we call it in main, for the drawing function, or like what they call view, we also want to use a view function that I also called view. And then I also already defined some interactive parts that are not in the standard setup, but I thought we're going to use them because they're like the most common ones. And we say like, hey, in our new window, I want to listen to mouse release events. So when we click and then release, I want to like call a function that I called mouse release. And if you have key pressed, I want to like call a function that is called key pressed. And then similarly, there's like all kinds of other event handlers if you want that you can like listen to. This is very similar to processing in P5, how like they handle events. And the last two are just like then build this entire thing, call on wrap, because that's what we do here. And then this is kind of like starts our window, starts our sketch, if you will. And then because the function actually needs us to return our model, so like the state, if we have one, we give it our empty model struct, even though it doesn't do anything, because like all the magic is already happening here, setting up the window and like registering stuff for us. Cool. Do we have questions until here? Yes.
Yes. I know P5.
Yes.
And in the typical setup function, I would also do things like loading fonts, loading images,
Yes.
and things like that. Would that be the correct?
Yes. Yes. Usually you would like, so like we will expand our model like at every kind of state that we have. And this is usually something where like, okay, I want to have like various assets that I need to preload. Because so basically the model is everything that you need that you later want to have access to in your update or also in your event handling things. So like usually in model, you pack everything that you need to load into your state, and then like later you can like access it and like read from it from everywhere else. So yeah, image loading, font loading, everything would go in here. If you need it later and say, oh, I want to like, I don't know, switch between fonts, and then you have like an active font or something. This is then something that you can override in the event handlers or in update or whatever. Does it answer your question?
Absolutely.
Cool.
Just a related question.
Yes.
When I do P5 for processing, I often use sprite maps.
Mm-hmm.
So I use, you know what
Yeah, yeah.
Does it need support Python?
That's a very good question. I don't actually know because I haven't used it with Manu. Okay, but we can look it up in the documentation if they actually do. But it's a good question, yeah. Other questions so far? Okay. I just quickly want to like go through the rest of the predefined functions that I put in there, and then we can take a small break, and then maybe like more stuff comes up later. Cool. Let's maybe go with the update function first. Like actually all of like our interaction or active functions here, because they're kind of like similar in the way that there's nothing really happening right now. But what we can do, so if we look at the function signatures, so like what arguments do we get and like what do we need to return if we do need to return anything, they're quite similar. So every function gets a reference to our app, so we can always access everything that's in our app. So this is the part that Manu built. And we get access to the model that we define, so like our entire state. And then depending on what the function is, we also get maybe like another kind of argument that we can use. So for example, key press gets app model and the key that is being pressed, and mouse release gets app model and the mouse button which I clicked, so we can access these. An interesting thing is that you may be wondering about what is this underscore here doing in front of all the parameter or like argument names. And this is also very Rust thing, saying that if you want to like define or name this argument, but you don't actually use it in the function body, you can prefix it with the underscore to tell the compiler, hey, I will not actually use this. Otherwise, the compiler will tell you, hey, you defined something that you don't use. Why don't you remove it? Like, this is kind of like Rust default, like compiler gives you these hints of like, hey, you have all this stuff defined that you never use. Why don't you just remove it? But maybe like in this example, like I want to know all like my entire function signature, but I want to know the names, but I don't want the warnings. So in these cases, I just like put underscores in front of them. An alternative way would be to use another attribute, like a hash thing that you can put at the top, where you can say, hey, I don't know exactly what the syntax is, but you can say compiler warn, like basically deactivate compiler warnings for this kind of for unused code or for unreachable code. So like, but the compiler also knows that the way you wrote this function, certain branches will never be reached. So like, look at this code basically. So the compiler has very useful things for us to consider. Another thing that I want to highlight here is that app gets passed down as a regular reference, as an immutable reference, but model gets passed in as a mutable reference, so with &mute. And this is an interesting part where basically once we construct the Nanu app, it stays immutable throughout our program, so we can like read from it, we can read the settings of the window, but we cannot like change it again, as opposed to the model, which is the state that we defined and that we probably want to change because we want some interactivity, we want something that's going on, and we want to maybe also probably change the state, change our model. Which brings us to the view function, which interestingly gets a reference to app and an immutable reference, so like a regular reference to model. So like the view function, which is just drawing, cannot actually modify our state. And I think this is really cool because I've definitely had it in the past with P5 or something when like you're quickly scripting down something and it's like, this should work. And then you realize while you're drawing that you kind of need a different value here. And then you start kind of like rewriting your state in a loop that is kind of like unclean. And then Nanu says like, okay, this is view, this is just for drawing, and make sure here through the type system that you can't actually modify the model, only modify it in places where you're actually allowed to do this. And this is really like cool because it forces me to actually pay attention to like where I do what, so that like later I still know what is going on. We also get frame, which is the actual image information that is then being printed or like being displayed. Which has to, like, I also thought it was kind of a little bit of, let's say, not ergonomic to me, but it actually has to do with the way that the graphics pipeline, or like the dependencies and like this is handled in Rust. So this might actually change maybe a little bit. Maybe they also keep it because they're currently rewriting or like updating part of the rendering process of a Nanu app where, or like the idea or the goal is that you can take your Nanu sketch and compile it to a WASM target so that it runs in the browser. So you can like either have it as a desktop app or just like in the browser. But this is not yet, this is ongoing. This is not yet done. This has to do with like the switch from, I don't know what they used before, but they're now switching to WGPU, like, is it called that? I think so. So like basically the underlying foundation that is used for graphics processing and drawing, which is a huge deal because like I don't really know where this starts and ends. I just read the GitHub tickets, but this might change. The important part is though that in Vue we get this little bit of a little scaffold for like actually drawing. So we saw the black rectangle in the window, and this is actually something that is already defined. We get from the app, so Nanu, the Nanu app gives us a draw function, and then from this draw, yeah, it returns the draw type where we have various functions that are or that we are probably familiar with, something like background or color or we will see like ellipses or like rectangles that come from this like draw type. We also have various colors defined as constants, so this can also be red. There's also like different ways to define colors, which we see later. But in the end, so this is the most important line, is that we say draw, we put it into a frame, and then this frame basically gets handled to like the actual rendering, so that this is what makes the image appear, and call on rep on that. So this is the walkthrough of basically the base sketch that is here. If you look at, or if you go to the Nanu website and find the guide. Yes, this one. All right. Just a second. So this is the Nanu guide. This is kind of like the Welcome Hello World, how do I get started guide. And they have under tutorials 3, like 0.3 is tutorials, and 3.1 is anatomy of a Nanu app. And there we have which is basically going through like what I explained in the base template that I used for our sketches, basically also this one, plus already some functions for key pressed and mouse pressed. But this is kind of like, we can also see that they used event for, okay. That's what I get for going off script. So what I used is the direct event handlers of key pressed and mouse pressed. But what you can also do is just call the more general event, which fires when any kind of event occurs. So this is more general, which might be interesting to just see, or like in a more exploratory way of like, oh, what happens when I press this, or like scroll here, or like what kinds of events happen. But if you already know, oh, I just want to listen for a certain event, I think it's much more readable if you just go for that event handler. But just know that like event also exists, and there's lots of events that we can look at or use. Okay, with that being said, I think I will just leave this here and like let's run the Rs binary, because I just changed the color to red. Let's see if that worked. And then we take a short, like 10-minute break, I would say, or 15 minutes. How do you feel? 10? 10? Okay, yeah, let's do 10 minutes. And then we can get into actually coding the walker. Maybe. Okay. Okay, this takes a long time. Let's just call a break. Maybe by the end of the break, my computer decided to actually compile this. So let's meet at 10, like at 10 past 2, and then go on by then. Cool.
And we are back again.
We are back again. Welcome. You can already see that finally at some point the sketch compiled with the background being red now. So that worked. That's cool. And now we can finally get to create our walker, like work with our walker here. I will quickly close this again. And then let's jump into the code. So I will also change this maybe back. Maybe let's not do black because it's not really that, doesn't really work that well on the screen here. But let's go with white. So my big question is, where should we start? With the idea being that we want to have something that kind of randomly walks around our like sketch, our frame or window, and then like draws something wherever it lands next. How would you proceed, or like what would be your first step?
Get a random source.
Get a random source?
Yeah, like
okay.
the random place and have random values.
Okay, that's a good idea. That also brings up a very, very good point that Rust doesn't come with a random number generator per default. So this is kind of annoying. Let's do that. This is also like very educational because we can check out a really, really important website called Crates.io. So we know Cargo is our package manager and it pulls in dependencies for us and compiles things for us. But these packages are called crates in the Rust ecosystem. So it's just like, kind of like a package, it's a crate. And we can search for things if you want to do something like, let's just search for random. And let's see what happens here. So it's random, and I really hope that there's also just rand, no? Yeah. So I thought this was a little confusing actually, because like usually the go-to default crate for random numbers is rand. But if a person that's just searching for random would not actually see this first, so now you know, search for rand and not random. And we can click here in the little clipboard, and then we can go into our Cargo TOML and add this as a dependency. Nice. Okay. This can also like actually teach us a lot of other cool things. Let's go maybe to the homepage and hope that there's a little, because rand can actually do like a lot of cool things. We will only use a teeny tiny fraction of it. Let's see. You can also see that a lot of Rust libraries are very fond of this kind of book format. So you will find these type of bookish documentation parts, like basically everywhere in the Rust ecosystem. And if they're nice and well documented, just as like rand is, you get something like this, a very nice getting started guide. And we once again see that we have a prelude that we can use. So rand prelude sounds good. Let's go back and use this maybe. And then how do we make a random thing? We just call random. Cool. So this seems fair enough. There's also more that you can do with random, like generate like within certain ranges and stuff, but like just calling random for us is probably enough. Okay, so we have the rand prelude. Maybe my next suggestion is that we go into view and just like try to draw something on a random position, right? Just to see if that works. Draw. And then what can we do? ellipse. Okay. And then Nanu has, so there's an interesting part where there's kind of like different functions, especially when we're dealing with positioning or width and height, that you, I don't think it's like super well documented yet, but it's kind of good to know, is that there's usually two versions of something. One is, for example, if you want to give it a position X and Y, there is XY and X underscore Y. And one takes a vector, like a vector 2, so like something that you would use in like a classic coordinate system. But if you just want to give it like two numbers and not coupled in the vector type, you can do X underscore Y and then just give it two numbers, like comma separated. And the same works for things like width and height too, for example. So let's go with this. So there's vec 2, I think it's called, or is it vector 2? I don't actually know. Let's see. Vec 2, yeah, okay. Where was I? Wrong. We're here. And then I would just try and call random, comma random. And give it a width and, let's go for the same width and height every time for now. Let's say maybe 10. And all of these usually take floats. Maybe like this. And we can give it a color. And now we're drawing on white, so let's maybe say blue. Okay. Let's go. Hoping that this is a little faster right now. Yeah. But the idea is then like that we just pulled in something that we can use to create randomness for once, and then just like try to draw something at a random position on every like call of our draw function. Okay. Now that we pulled in rand, we also need also compile these things. Let's maybe take a second. Here we get like no, that's okay. Yeah, that's right. These should actually be lowercase so that we do get the actually like functions and not the type. Didn't think this would take so long. Okay. Yes, question.
What kind of device is this push, pop, translate, rotates? That makes it much easier when I do subsequent drawing of rectangles. And is something like that supported here too?
Yes. So what you would do is, for example, say, or like you can basically create new instances of draw. So let's say this is like draw 2, and this, and then this creates something from draw where you translate by, I don't know, something, and then like move it, and then you, yeah, okay. Okay, let's see what's going on in our compilation here. Hui. Okay. Okay, let's just assume this works, and if it didn't, we'll have to check in a second. So what I would assume to happen is that once the window starts, we get random splotches of blue circles somewhere on our screen, which is good in a way that we now know how to draw a circle on a random position. But what we kind of want is that we want to start at a random position, and then from there kind of somewhat random, but still in an organized way, keep walking, so like we can kind of get a trail of these things. Let's see. Maybe now. Okay, this is also not what I imagined. Okay. I don't know if you can see it on the projection, but I can see it. It's kind of a blue circle that is kind of jittery in a way. And I forgot to tell you a lot of things. So the assumption I was just talking about was that there would be several, but this would that is not true because we also keep drawing the background every frame, so we only draw one circle at a time. So one option could be to just not draw the background, or like draw the background once and then keep the circles happening. The more interesting part here is the usage of random and the coordinate system that we're dealing with, that I completely forgot to talk about at this point. So what is happening? So we're drawing the circle basically right in the center of our screen. And this may seem counterintuitive, especially like coming from like processing or P5, is that when you're used to dealing with the coordinate system is that usually you start at the top left, and then like you go to the right and to the bottom. Nanu doesn't do this. And then I think this is one of the biggest what is happening here. And Nanu's coordinate system is kind of, think of it as almost like a polar coordinate system, if you will, but like basically the center of the screen is 0, 0, and then you go up, that is -1, and then you go down, that is 1, and if you go to the left, it's -1, and if you go to the right, it is 1.
And if I resize the window, the center changes.
And if you reset, well, it should still be 0, 0, right? Let me see this.
Yeah, it's still in the middle.
Yeah. Wow, my computer's laggy. What's the reasoning behind this, and why this like 0, 0? Because like we did define like a size, but like internally, how does this work? And the reason for this is if you, or like maybe if you're somewhat familiar with like shader programming, this is very common in the world of like shader programming, because then you can normalize a lot of things, and it's very easy to do math on this like very constrained things. You can like map basically any value within these ranges, and it's just it's what like it's also usually the default in in the kind of, let's say, the creative coding sphere, when you do with like creative coding and fragment shaders, for example, when you then say, okay, I want to like map sine waves to something, and then sine waves also usually go from like -1 to +1, and then you can like map these values easily to certain other ranges. So this is the idea that also Nanu has, that we start in the center, this is 0, 0, and then we can basically map all kinds of other values, and basically build the coordinate system that we want. So this is interesting. The other point is that, so we started 0, 0, this is here, The other point that happened is why this little circle is really just only minimally walking, like barely visible, is that random, I would assume, I didn't actually check this, the random function from the random crate would probably just generate a random value between 0 and 1. So like also like we get a float, but it's like very, very tiny. So we kind of need to make this a little bit bigger. So just for the sake of trying this out, let's multiply by 100, just to see if my assumption here is right. This hopefully is a little bit faster. Okay. This did not work now because specifying the generic argument. What is happening? Okay, now it complains about our type thing, so we might need to do this differently anyway. Okay. Then let's put it here. Let's say, no. Let's say X. And this should be X and Y. Wow. And this is where my Emacs shortcuts don't work. Okay. Okay. Oh, now I have a typo in here. Random.
I wasn't able to start the things because I was missing part of the Vulkan driver.
Ah.
So I installed the Vulkan driver and it works.
Ah. That is a good. Is it? I thought.
The random crate has the random generator thing, and if you don't want to use it, there's a shortcut of get rand.
Okay. Good that you know that, because I would not have known that. So get underscore rand. Okay.
Oh, you're right, it's just random. But it's random, colon, random. Unless you have
What we already used. There's also thread RNG.
Okay.
Then you can specify
from there. Okay. But did random work for you in this kind of scenario? No. Because that's what I had before.
Yeah. Yeah.
So I'm wondering why it works.
So yeah, you just have to specify the type for a function of like the turbofish syntax.
With the turbofish, because I was wondering if I just put it here, it should also figure that out. But I guess not. Okay. And let's try it like this, and then we learn about turbofish, which is also nice. So there's an operator, colon, and then angle brackets, and then we usually write a type. Is this correct? Yeah, okay. That is lovingly called turbofish. Do you remember the website? Is it turbo.fish? Okay. And now you never forget. And yeah, later on when we get to more, when we get into like iterators, we will also probably see turbofish again, which is just a shorthand of like telling, for example, a function that is the type, like the output type that we want. It's just like a different way of like defining or like, indicating the type that we expect or that we want. And let's see if that works. Now I just realized I also removed the multiplication again, right? Jeez. Actually, while we stare at this, or while I stare at this, I can also like, here's the kind of like annotations that, or attributes that you can put into hide compiler warnings. So like where we previously had derive, here it says warn, and then the type of warning that you maybe want to like mute for your project. So in this case, unused imports, even though we technically use something from here, but there's also like unused variables, I guess, and other kinds. Let's wait for a second more. Okay. Yeah, and this is the one without 100. Should have probably configured this to be faster. Sorry about that. Okay. Maybe we will like wait for a second until the window hopefully pops up again. Once again, talking about like what my assumption would be, what's happening is that we still get the same window, but like now we get like a bigger step of like randomly drawing a circle around the center. We can actually work with this for our walker, but like we already had the question really quickly, and I want to explain a little bit about this. The same way we get like the draw that we use is just an instance of draw that we get from app. We can define new instances of draw, either like freshly from app or basically from another draw instance. So let's say if we wanted like a classical top left, let's call it that. Whoop. Top left coordinate system, we can say we want to get draw, and then we can say translate. So that basically shifts our coordinate system. And what we can do is then say, basically want to take everything and then like shift it to the left and then like shift it to the top. So we can say, take a vector of 2. And now I'm actually not sure if we should, here's the window, finally. So this is more like what I was assuming would happen is that we, somewhere around the center, but like notice how we do stay within like the this quadrant of our coordinate system, basically. We draw this random circle and it's like jumping all over the place. But yeah, so like the random works, multiplication with random works, but we see that we need a little bit of work on our coordinate system. So what we can do is either start like what I was about to do is start shifting the center point from like the center of the center to the top left, and then we can say, okay, we always know that we need to like do something in this direction. For whatever reason, like it's also interesting to think about that you really have this freedom to play with the coordinate system. Let's say if you want to have something that starts at the bottom and then like shifts to the top, maybe you like want to start something and then kind of like flip it with like a negative scale or something. So there's like multiple ways that you can work with this. But let's start with like the translate it to like a more conventional coordinate system, and then go from there. And what we can do is that we shift basically the width that we have divided by 2, -2, because we need it to the left, right? And then we do the same to the top, where we say width divided by -2. And I really hope this works. Okay. And then, so this is kind of, it's actually, where is it? Here. So I can use these simultaneously, so I can still use the original draw to draw the background. But I can also say, from there on, I want to use top left. So here, instead of draw, I can say top left, and then use this to draw the stuff. I also don't need to change the last line because, like, since top left kind of like comes from draw, we can just like use draw to then draw the frame, and that should work as well. For now, I will also comment out the draw background so that we can actually see, or like better see, what's happening with the circle that we draw. Let's see. Let's run this again. Does this not work like this? Next function from draw. I'm confused. Let me look into my cheat. I don't actually use this in the final version. It should though. Maybe it's not the function call, but whoop. Just like this. But it should work like this, maybe? I don't know. I thought it worked the other way around, but no. Let's see. Nope. Expected spec 3. Oh, okay. Well, that we can do. That's not what I expected. So instead of like, it also expects us something for the Z dimension. But let's just not shift that at all. I hope that gets like just a 0 then. Yeah. Let's try. Whoop. Nope. Fascinating. Okay.
When I run it with 0, it doesn't do much.
But it also doesn't shift the rest? No.
I'm rerunning it now.
Okay. Okay. Well, let's look into the documentation maybe. I'm just kind of avoiding this because my internet seems to be kind of slow. Yeah. Let's see the chapter for window coordinates. Okay. So it did shift for me, but not in the way I expected it. So I had like the wrong direction. So I stopped painting the background, but apparently I did negative and negative. Okay. So apparently I said the wrong thing about the y-axis because now we almost drew like a little square. So we see the bounds, also like a nice way to see the bounds of our like randomness multiplied by 100. Okay, so on the y-axis I actually need to go in the other direction. Yeah, so negative is bottom. Wow, so I got really confused as well. So here it's 2, so we want it at the top. And then we kind of like should get the same thing. I will not recompile this right now because this takes too long. But it should kind of, we should get some.
I noticed that it used the top left, but still
okay, cool. Cool. That being said, so we see that we get lots of random points, but we still don't have a walker. And the idea is now that we start tracking our states. Instead of just randomly drawing, we finally make use of our model and try to keep track of like all the points. So the idea is that we create some sort of vector, which is usually the type that you want to go for in Rust. There is an array type, but arrays can't grow or shrink in size. So we use a vector, which is exactly, or does the things that we wanted to do. So on our model, we say maybe positions, and that should be of type vec, so like we get a vector. Don't confuse this with the vec2 and 3 that come from Nanu that we've used before, which we see right now because like this will be a vector of vec2, so like what we used for positions, vec2. So that basically the idea is that every time we update, we calculate, like we put a new position in there, and then like draw all the positions at once over our background. So that's the idea. What we also need to change is that in our model function, so where we set everything up, we now have to create like a proper empty model. So let's say positions is we can use the vec macro here to create an empty vector, and then we can actually, yeah, let's just start with this. Get this error here. Let's just start with one random position in the beginning. So we have something. Where did I do that? Here. Okay. Just put it into here. Okay. And then we say this is our first vector of x and y. Positions. No such field. Did I write this wrong? Positions. But that should be okay. I don't know. Let's see. Now here comes the cool part. I will now delete this. So we get, now that we put our first initial random position in our model when we created it, I will quickly go back. Also hope that the red underline disappears in a second. So we have modeled with a vector of actual coordinate positions, but we only put one in there for now, just to see if that works. Then what we had before in the view, because that's actually kind of more logic than should be in the view, I will delete this. And then we can actually read our coordinates from the model. So I actually need to, basically, I will remove the underscore from the model here in the function signature. If VS Code will let me, yep. So we get model, we can read from it. So here in XY, I can now say model, and then positions, and then 0 or something. And this is interesting because right now we're only drawing one, so this could work for now. I will quickly actually check if that works like this because I don't know.
Is this the type intuition struct? It's really that red hands. I guess if you scroll up to the struct, it's called position. This is why.
This is why he was like, thank you. Yes. Beautiful. Yeah, let's wait for it. So this is just like a next small step in changing the code again to see if okay, can I actually access the model and the positions in there? I know that in the next step would be, we will not have just one position because right now we only put in one position in the beginning, but we want to actually keep pushing in positions and then draw a circle for each of these positions. Which leads us to one of my favorite topics in Rust, which are iterators. Yay! So iterators are everything that has to do with traversing a list or a collection of things. An iterator is a trait also in Rust, even a vector that we saw implements the iterator thing, or the iterator trait. And the best part about iterators is that they open up the entire world of cool functional things that we can do in Rust. That, I don't know, it's this cool thing that I said in the beginning that I did a little bit of closure where I was everything is just map and reduce and all this kind of stuff. And then you can do all these things with your collections of data in Rust as well, but not having to worry about any kind of overhead for performance, because once it compiles, it will run super fast. So you don't pay for nice higher level concepts, just as these functional features, but you basically get them for free. And this is really exciting. So there's different ways we can, now we have this little window and we see nothing actually. This is unexpected. Where is our circle? Where is the circle? Yeah, but I think I know what it is because, I don't know, there should be a chance that it just, we got unlucky with our random, nope, okay. So
this is applied the transform function and it just jumped outside the view.
Really? Because before I was so No. The thing is, random should only give us a positive value anyway, right? So it should... Do we need to... this coordinate stuff. So we started from here, and then we shifted negative and positive. So we should be here. So if we have a positive value, we should end up in this. No. Because, okay. So it now fooled me twice. Because negative is down. So we kind of need the second value or the second random value to produce a negative value, or we flip the coordinate system again. Maybe this is better, because otherwise I will probably make the same mistake again. Nope, not here. So after translating, I would say scale, and then keep 1 for the x-axis and -1 for the y-axis, and that should flip it, right? That is, yeah. Actually, is this scale y? Yeah, okay. I will try it this way, and if it doesn't work, I will try your way.
Side note.
Yeah.
When last time I did graphics on
computers,
the 0 point was on top left, and X was going right and Y was going down.
Yeah.
So why did they flip it?
That the Y is flipped right now, I'm also absolutely confused by it. Like I did remember the reasoning for the center position. Like, yeah. But why they flipped the Y, I don't know. I would maybe reread because there's a blog post where they explain some of like the design choices that they made. Maybe it's in there and I just forgot. Maybe it's also not in there. I don't know. But there's it seems kind of, yeah, not what you expect. So this is, yeah. So I've now ran into this twice in one session because it still seems so. What I'm thinking of right now, if I flip it, do I also need to adjust the other translation again? But I
feel like we're diving.
Yeah, this. Let's see. Maybe it's just easier to multiply by -1 and then in the random. So it's because if we no, it worked. Okay, so we get a point within our now correct coordinate system. Hooray! Fascinating. So we're only generating one point right now. So this is fine. This is expected. And I guess you can also see how I usually go about these things. I try to do something, think kind of like imagine what should be the outcome of what I just did. And then either it is that outcome and then I move on to the next step, or it's not working at all. And I try to figure out, okay, did I think wrong or did I write wrong? To go like kind of, this is my approach. But maybe like once you're more used to both the tool and the like this kind of way, you probably like write these way faster and more confidently. Okay, so we have finally settled our top left coordinate system. We generate one thing. We were with iterators. So what we actually want to do is draw a circle for each of our positions in the vector. So for the sake of just showing it, so there's simple for loops that we can use. So let's call it for position position in model positions. I'm really bad at typing this. Positions dot iter. So we want this as an iterator. And then we already see, like Rust Analyzer says, okay, now we get this vec2. Cool. Well, no, that's, oh man. Let's take everything here and move it into here. And then we can just work with position here and not have to worry about the rest. Cool. Just position here. Cool. Before I start trying to re-render this again, let's also just add the code to the update function to tell, like basically adding a new point. Otherwise, we will also just get the same point again. So in this case here, let's go into our update. I already removed the underscore from model here. So what I kind of want to do is basically do the same thing here again. And let's not multiply by 100, but let's actually multiply by width. So we get a random value that goes over the entire canvas of the, or like of our window. Whoops, width, like this. And then, so we do the same thing here. And then I would just say model positions. And then we can push because it's a vector. Oh my God, push. And create a new random XY vector here. Whoop. And then let's try this one. And this time we should, and I also want to bring back the drawing the white background. So we can see, so now every time we draw, we should really draw every circle in the position because we also redraw the background. So yeah, I hope you get what I'm, no, what's happening? So this is an interesting error that we haven't talked about. I used words like references before, but here we see kind of like the counter side. So in the iterator that I created, I get position. So like each element in the vector, I get it as a reference to a vec2. But what the XY position or like the XY function really wants is just a vec2. How do we get around this? The compiler actually already has like an idea what we might want to do. It says, oh, help, consider dereferencing the borrow. So borrow, and it's basically saying that we borrowed something, we get a reference to it. So we kind of like borrowed this value, let's say temporarily, or like without the intention of modifying or mutating it. And with dereferencing, we basically say, oh, I have this reference that I borrowed, but I can walk along it and see what is actually there at the end. Like, what is the reference pointing towards? And then we can like look at this value. And this is done in Rust with the asterisk operator. So basically saying, okay, if this is a reference, I can use the asterisk and say, okay, walk down this reference, which is points to an actual value, and then we want to use this value in our code. Let's go to here and save and try again. Yeah, and you will see that oftentimes, like, I don't really think about references and borrows in advance, I most of the time rely on the compiler to tell me, I'll try this or try that, especially with dealing with Nanu, because Nanu sometimes has very opinionated ideas of like what it wants right now. So that like, oh, maybe it's like a dereference to something is not uncommon in a bigger sketch or in a bigger project. Whoop. Okay. Well, this, yeah, it's sadly my computer died 2 weeks ago, and this is it's a borrowed laptop, so I can't really talk bad about it because I'm happy that I have it at all. But yeah, let's see. Maybe let's go on after all. I'll once again tell you what my assumption is that will happen once we have the video, once we have the window, which is that we still get like random points all over our screen, but still no walker. Yes, kind of like random dots, and it's like, okay, but where's the kind of idea of like, well, we're following some sort of trail. So this is the point where we need to like think about like how do we get from like one okay, we can start randomly, but how do we go from one position to the next that is somewhat random but still like connected in a way? Any ideas? That's actually an interesting idea, but I thought of something that's more simple. It's just math.
You look at the last point.
Yeah.
Add the delta in the random direction.
Basically, we take the last value and like go from there. Cool. Let's do this. So we already have update, so we can kind of how do we do this? So we say we get maybe the last point. Oh, or not the pint, but point. Oh my god. Which is model positions dot last. Does it exist? I don't even know. Does it?
Yes.
Yes.
Then you get an optional, and then you have to match it.
Okay.
Or we can also just be blunt, because we have construction insert the first element. Or you can do both. It depends if you want to
Let's talk about
efficient with inserting, right? Then you should insert at the back. Or if you want to be lazy with coding, then insert at the front.
I would probably be lazy with coding and insert like this. But now that you mentioned the option, because that's already a good point to talk about last. So this gives us an option. I hope that Rust Analyzer will quickly run. Yeah, so it's an option of a reference of vec2. So what would be really cool, so like in the way the program runs right now, that we know that there will be at least one position in the vector, because like I put one in right when we create it. But there's a cool thing. So there's this entire topic of pattern matching in Rust, which is also really cool, where we can match on things, and especially enums. What is an enum? Enum is a type that has a strictly defined list of variants. That means a strictly defined list of things it can be. A classic example would be if we have an enum of traffic light, and then the variants of traffic light would be green, yellow, and red. At least like where traffic lights look like this, not in other countries that have blue lights. But the idea is that we can say, okay, if we know that we're dealing with a type traffic light, we know that it can only be one of these 3 variants. And in the same kind of way of thinking, option is an enum, and option is either some thing, so the one variant is actually called some, S-O-M-E, or it is none when there's like nothing. And then the sum will contain something that we can work with. So what we could do, so like the way pattern matching works is that we have the match statement, and then we can say last, so we match on last point, and then we know that it's either sum of something X. That is actually, where are we? Nope. Where am I? Here. Then we can do something here, or yeah, it is none, and then we can do something here. So let's say we match on the option that we get, and then do something with the next value. But there's also a shorthand for this entire expression if we only dealing with the with this concept of option, and that will be I put this at the top to like then compare it to, which would be if let. And that is sum of, let's just call it last, and last, oh, come on. Last point. And I hope this is correct syntax, because I also always make a mistake here. So basically, these 2 are equivalent. It's just that in the if-let case, I'm saying, okay, I'm interested in whatever is in this object. Like I want to access it in like a safe way, but I'm really only interested in the sum. I don't care about the none case. So like in here, I can then use last and do something with it. And in the other case, in the match, I'm more explicit. I can be more explicit about doing something for each of the variants that I might be that I can match on, so to say. That was our first part for match. We will also see matching later, because like there's like we will also define an enum and like look at how that works. But let's go with the if-let for now. Or like maybe for completeness sake, there's also like other ways to just access the option or like the sum part of the option, which is with unwrap, which is something that we've seen before in this as well. This is just taking the sum if there is some, but like crushing if there is a none. So this could potentially like crash our program because it's like not really good error handling, let's say. So like a nicer way would be this. So like finally, let's get to our last point. And let's also say actually that I want let last, and then we dereference this here, I guess. So I can get this. I will also remove these two. Just so that I can have a little bit of an overview. So if let last, and then we said we want to say, hey, let x be last dot x plus random turbofish, just to be safe here. And then that's multiplied by maybe let's go for 10. So just like we have a little bit of a distance that we can walk in between these two, like from the last position to the next position. And then we do the same for y. And then we also just pull this one in. In here. So this is one problem right now, but I think we will see this once I'm already going to kick off the running this. But the idea is that we update, we get the last point. Only if we actually have a last point, we construct a new point that is like goes a little random step on the x and on the y axis, and then we take this new point and then push it in. What I already kind of assume is going to happen is that we will only ever walk in the positive direction, because like now that our coordinate system is made in a way that positive only means like going right and down. This is kind of like where we're walking here. Oops. So we kind of like have to also think about, okay, like now, how do we generate a random point? It might also be randomly negative. Are we done yet? No. So there's various ways we could do this. Maybe this time we can actually work with range.
Just like double the 10 and then subtract the 10 again. So
Yeah.
Multiply the 20 and shift by 10.
That's a good idea too. But then we have to. Should be fine. Nah, I like it like this. So I know like what steps I want to belong together in a way. Okay. And let's maybe try this one directly. And this should technically already give us a walker in a way. The rest is then like visually improving the outcome. I want to say one part about, because we heard Perlin noise before. So this kind of motion would be Brownian motion. So like just like randomly, really uncoordinatedly walking into a direction. The biggest difference to Perlin noise is that Perlin noise is pseudo-random. So in this case, if we have a walker like this and we like generate an image based on this, there is no way we could ever like get the same or like replicate an image that we had once, because like this is truly random, or like as random as a computer can make it, I guess. But if we say we want to have an algorithm that can be reproduced, because there's let's say it takes a very long time to compute, and then you don't want to like you only want to like send, or like, I'm going one step back. Perlin noise is pseudo-random. What that means is that based on the seed, the algorithm will generate the same sequence of random numbers based on the seed. So if you use the same seed again, you will get the exact same sequence of random numbers. So let's say you could share an image, let's say by sharing the algorithm and the seed, and then the person can compute their own image, and then they would get the same image. And this can be really cool. Here we go. It compiled. It's a walker. Amazing. Yay. Yes. So this is one idea that can be really cool. Nanu comes with Perlin noise. It is, I think you have to explicitly import the, I don't know if it's really just like Nanu : noise, or if it's like in another package, but it is already in there. So you can get Perlin noise from Nanu, give it a seed, and then like generate randomness based on that if you want. Right. Cool. No, lost forever. Okay. Questions so far? Okay, no. Cool. Yeah.
So what was the name that you gave this randomness, Brownian or
Brownian motion?
Why is it called Brownian motion?
Because I guess there's a person called Brown who defined. It's also like brown, like German brown. Also, Perlin noise is named after Perlin. No, it's actually not. It's brown like English brown. No, I was so sure. Yeah, but there's like different kinds of these, like. Okay. Yeah. So like, yeah, this is basically like any kind of like super random. Yeah, it is. Cool. Let's play a little bit with the color things in Nanu, because I think that is also something that, or to me, was not like super intuitive when I first started. Right now we're just like drawing a color, like just the color blue, that was like predefined. So I think they're based on the CSS color names. So you can also use your cornflower blue or whatever you have. But it would obviously be cooler if we could just like either use RGB or HSL. So like, RGB is like red, green, and blue, what you use from like web development, or HSL, hue, saturation, lightness, which is a different kind of way to like describe colors. And in the final example, so like there's various ways that you can bring color to your walker. This is also like the part where we can open it up a little bit more, because like this is now the very basis, like whatever you want to do. Because like, for example, you can play with the width and height values, like we just defined them here, but you can say, oh, I actually want a random width and height for every position as well. So you have to adjust your model a little bit, not only to keep track of positions, but also like maybe like wrap everything and like call it each step, and each step has a position and a color. For example, you can also, change color on click. This is like the last step that I want to do with you, is like looking at one of the event handlers that we have and how to work with those. But maybe we do this when we look into the final.rs. But like, yeah, now it's the part where you can like think of like, oh, wouldn't it be cool it could do this or that? And for this, I want to quickly do the color thing. I want to like, because we did it here, because I thought that was also kind of interesting. So what I did in the original sketch is this thing. I defined a variable and used map range. So this is if you come from P5 end processing, it's just called map. But since Rust already has a map, then we decided to call it map range, because this is what it does. Is that it takes a bunch of arguments. So the first one is the value that we have. So this would be here. Actually, we need to put it in. inside here, because we need this for every position. So the idea is that we have, dereference position, position X, and then we know that the position X will be within the range of 0.0 and the total width of the screen. This is like from the pool where we generate its randomness from. So it's like this is the input minimum, 0, 0. Or maybe let's do it like to the output, or the input max, which is the width of the window. And then we kind of like want to interpolate based on these values, want to set like position X to a different kind of range of values. And in this case, the idea is that we then go in the color wheel, in the hue space, we want to pick a value here, and in Nanu, this is defined on the scale, or like on the range from 0.0 to 1.0. This is why these values are here. So map range will like then map these values from one range into another for us. So this is kind of cool. So then I will also so instead of just using blue here, I will also copy this because I'm getting lazy. We can do this here. Whoop. Wrong thing. Right. So instead of calling color and giving this predefined color, we're calling HSLA. Once again, that's hue, saturation, lightness, or sometimes it's also called brightness. And then A for alpha, where hue is kind of like within the color wheel of the, maybe I can, maybe it's easier to quickly search for an image. Yeah. So if you imagine this like color wheel that goes, or like, that goes like, usually it's in degrees because it's a circle, from 0 to 360 degrees. Sometimes this is already mapped from 0 to 255. In Nanu, this is mapped from 0 to 1, but basically every value describes an angle within the circle. And then we move the radius from like darkness and lightness, and then also in saturation. So any of these kind of ideas. And the cool thing is, if you want to be artsy, you can easily set, or like only use randomness on one of these channels and set the others to a static value. So that like because usually if like saturation and lightness stay the same, the colors kind of like seem to work really well together. And then you can say it's totally on purpose, if you want. So let's maybe go up with the randomness here. So I'm set. So like hue is going to be the map range based on the X position on this color wheel. So like we don't have a circle, but just like basically going from left to right over the, so like from red to basically red again. They're wandering, or like meandering through the color wheel, but only on the X-axis. And then saturation, lightness stay the same, and a little bit of transparency, basically. Let's see this again. And once again, made a typo in position, because this is my word that I cannot write. And it's still not right. And I thought I was being smart. It already tells me, oh, this is by accessing the X value, I already dereference it. also for reasons that I don't want to go into right now. But I really hope it's working now. Yeah. Yeah. Cool. Okay. Yep.
Do you have like a delay minimum, or is it just like how often is the update function?
That's a very good question. What do you think?
Well, worst case, it's basically bound to the CPU, so it's as often as possible, which then on my machine would fit in into 60 repetitions because of the driver. Best case, it's on a scheduled interval, but I don't know.
So what these kind of frameworks usually try to be, they aim for a constant 60 frames per second in everything, in the update function. So this is when I say. And there is, you can configure this, like how often you want this update function to run. So the default is 60 seconds, and there is, let me think. So there's multiple ways. You can even say, oh, just don't update at all, and then through code, say update. So like, for example, every time you click, calculate update, to like basically step through a sketch. Oh no, where's everything? Is it too light, maybe? Sorry, I'm just like quickly. Try this again here.
So you can configure the update frequency?
Yeah. This should be somewhere in the documentation, but I think I also have a, because I did this before in one of my, let's see. I think it might just be called frame rate, and then you put it in when you create the window, like in the model thing. But I'm gonna check. Loop mode. That's also. Let's see, because I had this actually at the Russ Linz meetup. Where is the model? Here. Did I not? Oops. Oh. At least the window is here now. So we start here and we see like basically the left edge is now red, and if the walker were to walk a little bit to the right, it will like cross from like yellow and then green into blue into purple into red again. Unfortunately, it decided to leave leave this now. So maybe let's try again. And then we start at the other edge. Eventually, we get a good example, hopefully. So here we are, like in the blue and purple-ish space. And Another idea could then be to like map, so I only map the X value to hue, but for example, you could also map then the Y value to like brightness or to saturation to get like even more dynamic within the sketch. So this works, right? Because it's only half an hour, and I kind of want you to like really like play with this, and I just like can be here for questions. I'll quickly run through what like the final result is or was, or like what like my original idea was, just to show you how like what else you can do and how you can go about things. So you can also look at this in Final RS. So what I was thinking is that you could, instead of circles, draw rectangles or dots or something else. And then I thought like, oh, we could create like an enum. So like this kind of type that can only have certain, certain variants, can be certain states. You use it with the enum keyword, and then I called it viz for visualization. And then I just said, I want, it's either dots or circles or rectangles. And then like basically there's, all right, we can look at this. I derive some like basic traits for them. And then I have a struct that I call walker, where I keep track of the steps, which is a vector of a tuple. We haven't talked about tuples, so you can just with parentheses, basically like, group some values or types together. So this tuple has a vec2 on the first field, and then a 32-bit float on the second field. So I can like say like for each step, I want to like collect this information, and I think the f, like the float, is then used for the distance that we used like in the calculation of random. And I also want to keep track of the style that is currently being used and then that I want to draw in. And this was an interesting decision because like you can go either way, right? You can say like, if I keep track of all the positions with the press of a key, I can change the way it's like drawn for everything. Even it was like previously they were all circles, but then I press a key and then they're all rectangles. But then I thought, wouldn't it be cooler if I say like each walker has one style, so then I can have multiple walkers and each walker has like a different style of visualization, and then use that. But like this is then like your artistic and creative freedom to go with this. What we also haven't talked about is the impl keyword, which is I talked about when we derive something, the compiler generates the implementation of a trait for us. If we cannot or do not want this, or just want to do something different, like implement other functions on our types, we have to open an impl block, and then we can say, so for a struct walker, this is basically just struct just defines the fields of our type, and in impl we can then bring functionality to our type. So we can say, for example, we can create an explicit new function, so that we don't have to use the manual like full syntax to create an instance of our type. I also decided here to actually maybe go a little bit more into the maybe like object-oriented way, if you want, that I said, okay, each walker should be able to basically update itself. So I implement an update function on the walker that then knows how to do all the maths with all the steps that are in there. This seems very, there's a random vector. I'm also like clamping some values here. So I'm not like this. We chose a different approach in our sketch, which is also cool, so that there's like multiple ways to do the same thing. But then my actual model is then a vector of walkers, so that I can have multiple walkers. And then I also keep like style overall is kind of like the currently active one. If I create a new walker, it will kind of inherit, but just like copy the style that is currently the global one. So I like arranged the sketch like this. Yeah. So for example, when we kick off like this sketch, I generate one walker. Actually, it appears that here we didn't change the coordinate system at all. So I'm starting at 0, 0, which starts in the middle, give it the circles viz, and also like the overall viz is circles. And then what I did in key press is that so when I get the key, I can match on keys, like it's the same kind of pattern matching that we had with the option. But I say, okay, key 1, which is just like the number keys in the top, I want to change the model style to either dots, circles, or rectangles. Interestingly enough, this is also something that is kind of interesting and cool. So we have a default case, or like a catch-all, if you want. There's just the underscore that says like all the other keys, because there's a lot more keys on the keyboard than we want to check for. For all the other keys, just do nothing. We want to ignore them. But in this case, we have to put this default case here, because otherwise the compiler says, but what if any of the other keys are like pressed? I don't know what to do. So we have to be explicit about like saying, for everything else, just don't do anything. And this is also cool because for we saw an option earlier. Option only has 2 variants, so there's only some and none. So we covered all the possibilities in that case, and the compiler also makes sure that you provide one way to go for each and every scenario that an enum has. So you can, if you kind of like forget to account for a case, the compiler will tell you and force you to actually make sure you cover every case, and also and through this also eliminates like a source of errors if you run into something unexpected, or in case you run into something unexpected. That was it about match. Right. In the final sketch, a thing that I did is that when you click a mouse button, I have the same match statement here. Basically, we match on button. If we say, if we click with the left mouse button, we basically copy the position from the mouse click and generate a new walker. And if we click with the right mouse button, I basically remove all the walkers by just saying, okay, walkers is now an empty vector, and then we can start again. And I also need the fallback case here because some mice have a lot of keys, but there's at least also the mouse wheel that we need to account for that we can click. And the rest should be kind of self-explanatory if you walk through it. Cool. That is it. One thing that I might want to show, that the first time I gave this workshop, one of the participants had the idea that we do want a random walker, but we kind of wanted to sort of walk into the direction of where the mouse is, but still in a random way. So that was kind of interesting to do. So what we did is kind of like multiply the vectors of the mouse position. Yeah, here we go. That took us a long time to figure out in the workshop how we get there, from the mouse position to like normalizing the step size, and to still kind of like sort of like have the walker wobble its way towards the mouse. But this is also like an idea that you can in that direction if you want to go there. Okay. Questions? Oh, okay. What would you like to try? Or would you rather like try stuff by yourself and like I can like walk around and ask or like answer questions, or we can try something together, or there's like roughly 15 more minutes, or we can also talk about other things that may be interesting to you within the, yeah.
Is the new GPU accelerated?
It should be, but don't quote me on that. Yeah. Maybe other So I did say that a creative coding framework is basically just a game engine with extra stuff. If you want something that's maybe smaller, just for like drawing a little bit, there is a small game engine called GGEZ, Good Games Easily. And this is, so I think they're not active, so they're kind of like still maintaining it, but there's no further development on it, but it works. And you can get like most things done with it. It has this like update draw API that you kind of should be familiar with by now. They also have this like, hey, you define your own state through structs. Actually, make this bigger. And you can like draw simple graphics and like make simple games with it. So if this is, let's say, if this is all you want to do, GGEZ might be like a smaller crate that is worth looking into. But as I said, there's no more like active development, just like maintenance going on. But if you're actually interested in a game engine, I would recommend. Let's search for it. Recommend Bevy. Couldn't remember the actual URL. Bevyengine.org. Okay. So I think from my perspective, Bevy is kind of like the hot shit right now in the Rust game dev ecosystem. But Bevy uses, or like is based on like an entity component like architecture. So this is just like a new like way to think about how to structure your program. It might be like, if you're not familiar with it, it seems a little like weird, I think, at first. But it's cool, and like actually the community does a lot of like tutorials for it, and it's like actually kind of like cool once you get used to it. But this is like it's a game engine, like game engine. That's the focus. So like if you then want to try to like bring something, because like most other frameworks or engines don't really work with like this entity component thing. So like then trying to combine this with other stuff, I actually haven't tried, but I'd imagine that it would be more difficult to like bring different kinds of like architectures and ideas into the same space with Bevy. So yeah. I think these are the two things that I want to show you. Questions, input so far? I just keep on talking. Like, feel free to interrupt me. I also want to quickly go through the list of useful links from the pet.
Just a comment.
Yes.
Now played the whole time with this stuff is really awesome.
Cool.
Coming from processing this change of the coordinate system makes me crazy. I see so many things. I try to rebuild something that I didn't define, and wow, it's so unusual.
It is. Yeah. Yeah. I mean, I know that it's there, and I know that I've made mistakes in the past, and still I make all these mistakes today again, because it's like so. It's like it's really the only framework that I know that does it like this. If you're not just like, I don't know, writing raw GLSL shaders, which is like, and even then, I think even there you usually set the center point at the beginning, if I remember correctly. No. What else? And again, the rest is just no. Maybe that is actually also kind of cool. So I talked about nature of code and the generative Gestaltung or generative design books in the beginning a little bit, because they're kind of like two standard resources in the generative art or like creative coding space. But in the Nanu repository, there is actually the generative design and the nature of code examples from both books ported to Nanu. I think almost like 90% completely, probably maybe even more by now. So if you like read through these and think like, oh, like how would this work in Nanu? How can I like solve this? There's actually examples of everything in the repository. So that's like, while there's no, so like my biggest pain point with Nanu is usually, so like I like a nicely written out tutorial with like step-by-step things of like, oh, this is how you do this is how you do that. And this doesn't, while Nanu has the guide, there's only like the very, very basics described in it. And there's like 2 or 3 community tutorials. But the rest is still only exists like examples in code. So it's really just like you trying to like work your way through the code and like trying to understand what's happening. And with the way that I work with like seeing, okay, making one thing work and then like expanding upon it and like iterating over it, this is very hard to have this experience with the new material right now, which is, I think, a shame. But I hope or would assume that it like gets better in the future, because like Nanu is still like under active development. A lot of things change. There's still like more API things that they want to work on before they want to like attempt a like 0.1 release. So yeah, I think that's it. Okay. More questions, ideas?
I tried to implement the thingy, but I'm not sure.
Yeah.
I should ask you. Like,
sure. Which thingy?
The different styles.
Ah, okay.
That I made a video and then matched it.
Yeah.
And now it's complaining to me that different match arms have different types. Right, so big dots and small dots are both ellipses. Mm-hmm. But the rectangular, I started with quad. So,
okay. Yeah.
So do I have to like erase the type, or?
It is possible that I just duplicated the code. But I think, I don't know how it is for quad, but I did have some super weird things with line and polyline where I just had to like really just like clone some like it had like the weirdest kind of stuff, because like some of these functions expect really strange things. So I would just, my assumption is that it's something related to this, where it's like, oh, you but in my case, so when I did it, I just like copied the stuff. Yeah.
I will try to correct it.
Yeah. Yeah, like because like quad also takes a vector of points, I guess, or something. Because like I think rect is always like rectangle, and then quad can be like any kind of 4-corner thing. So like if you just want like the actual like 90 degrees rectangle, use rect, and then quad is more like, here are 4 points that describe any kind of, yeah. Which could also be cool.
I will make myself an easy life, which is duplicated.
Nice. Small steps, right? In the next time you can like improve on that. Okay. No, I talked for so long. Question, yes.
I'm still struggling a little bit with the difference between update and
view. Right? Yeah.
I put a small little app while listening to you, and I hope you miss anything, but my app deals a lot with scaling images. So what I did is I built a little Connect 4 and it scales to the size. So now I'm not really sure what to put into Octave and what to put into Vue. Because there is a lot of logic going on, scaling and things like that.
Okay.
Can you elaborate again more what I should put into Update and what I should put into Vue?
So the idea of Vue is that you just draw, and the idea of Update is that you modify your model.
Okay.
That is like the base distinguishing. I don't know where. Do you have any kind of like window resize handler or something that does stuff? Or
I do in the update method. I'm just accessing the as main window in SS. That works fine.
Okay, but you're not setting it again because.
No, I'm not.
No. Okay.
No.
Yeah.
So you can, if you want.
Yeah, I can take a look.
So.